What's the point of philosophy? Almost every person unfamiliar with the subject beyond its mere existence seems to hold in their mind some version of the idea that philosophy makes no progress. The claim is that philosophers still debate the very same things the ancient Greeks did, Socrates, Plato, Aristotle. There have even been philosophers themselves who have argued this position. Indeed, this was the position of the most famous philosopher of the 20th century, Ludwig Wittgenstein, who argued that philosophy makes no progress. And this is because philosophy, essentially, is reducible to little more than language games. There's nothing that philosophy deals with in reality, no actual problems, because actual problems are problems of science or of history or of mathematics, say. But philosophy is a domain where the same questions are encountered over and over again, simply because we fail to understand the limitations of language. It is language that makes certain things appear to be problems, but they are in fact not actual problems. They're pseudo-problems. Now, this is the position of Wittgenstein, and it is one of the most popular views in academic philosophy even today. And a plausible story can be told that this theory of philosophy, the linguistic school of philosophy, which is philosophy as nothing but language puzzles, gave rise to an inordinate focus upon language in philosophy broadly. It spawned postmodernism and deconstructionism, the idea that nothing much can be said in philosophy to illuminate the truth. And so, why bother even striving for clarity? If Wittgenstein had essentially proved the uselessness of philosophy as an academic enterprise, is it any wonder then that so many migrated away from tackling the big questions in the tradition of the ancient Greeks and instead turned to linguistic navel-gazing, or even linguistic obfuscation? If it's all a fool's errand, why really try? Happily, Wittgenstein and those who followed won only some battles. They haven't won the war. There is another perspective. There are philosophers who follow in the grand tradition of philosophy, of tackling philosophical problems and making philosophical progress. So to that end, I want to summarise a defence of philosophy by Karl Popper. Popper is rightly credited with determining the line of demarcation between science and non-science. He is sometimes remembered as creating a political philosophy and a defence against tyranny. He, or his philosophy, is often maligned, utterly wrongly, as a proponent of the idea that claims that are unscientific are meaningless. In other words, the claim is that he himself was a proponent of something like scientism. Mostly, for those of us who value his contribution, we see him as a much too forgotten philosopher of the first rate, the best of the 20th century, who solved many problems in philosophy and wrote far more clearly than almost anyone before or since on these matters. Popper had much to say in his writings and lectures over the years about Wittgenstein's position. Popper went to great lengths to explain the flaws of Wittgenstein's position in various places in various books. He rightly understood that Wittgenstein had given birth to an entirely new school of philosophy, linguistic philosophy, and it was ascendant. Moreover, Popper saw great danger in that approach to philosophy. Of all the work he produced on these matters, none come to bear quite so directly on the matter, nor in so concentrated a form, as his lecture, later turned into a paper called The Nature of Philosophical Problems and Their Roots in Science. This paper that I'm going to be primarily talking about today is remarkable because it demonstrates Popper at his best. Firstly, it demonstrates what it means to take an argument one disagrees with, even from a disagreeable person, and present it as powerfully as it can be. To take your opponent's point of view and refine it and express it so clearly that there would be nothing whatsoever that the opponent would object to. Indeed, they might even say, "Wow, that's an articulate and powerful way to put it. I wish I'd thought of that." This last point is sometimes called steel manning these days. I can't say that Popper pioneered it, but I doubt anyone has ever been more expert and dispassionate in doing it. For here, in this paper, he is responding to his great rival Wittgenstein. Wittgenstein, I must emphasise, is revered by somewhere between many to almost all philosophers as the greatest philosopher of the 20th century. Few others can lay claim to spawning an entire school of philosophy, the linguistic philosophy. One of those few others was, of course, Popper himself, who spawned critical rationalism. Popper and Wittgenstein met only once. That encounter is the subject of an entire book written on the topic, and much folklore in philosophy circles. The book, by Edmonds and Eidnow, is called Wittgenstein's Poker, and it's easily found on Amazon. It's about a discussion over the very question in Popper's paper, which I'm talking about today, and this paper wouldn't be published until many years after that encounter with Wittgenstein. And the question is, the central question of the book, the central question of the paper, and in various writings that Popper produced on this topic is, are there philosophical problems? So when Wittgenstein and Popper met, it was just a brief exchange between the two of them in October of 1946 in Cambridge, in the presence of many others, including their teacher and mentor, Bertrand Russell. Wittgenstein held that all problems thought to be philosophical were really just pseudo-problems. They reduced to problems of language use. The only real problems were mathematical or scientific ones. Popper put the case that there were real scientific problems. The reason the book is called Wittgenstein's Poker, by the way, is because at one point, and the accounts of the witnesses differ here, Wittgenstein lifted a poker to either move the coals in the fire or to emphasise a point, or perhaps even to threaten Popper. The extremes here differ depending upon the witness telling the tale. But that debate, and the book recounts it well, is the central concern of this philosophical paper that Popper wrote in 1952 and published in the British Philosophical Journal. So it was some 6 years after the encounter with Wittgenstein at Cambridge, and after Wittgenstein's death, which happened in 1951. One might even see it as Popper's tribute to Wittgenstein because, as I say, he has steel-manned Wittgenstein's position, as we shall see. Now, Popper writes exceedingly clearly, but even exceedingly clear professional philosophy at Popper's level can be obscure to the novice. Moreover, mere decades can cause language changes to the English language, such that what was once clear is now perhaps somewhat arcane in places. So I want to explain Popper's paper in my own words. Why? Why bother with such an obscure paper about an obscure question debated by philosophers from the last millennium? Why now? What's the point? And what's the importance of this paper to today, some 70 years later? Well, the last few years has seen postmodernism and relativist movements go from strength to strength. And in the last 5 years alone, we've seen a surge in nihilistic or pessimistic politics and rejection of truth in favour of a strange alliance of relativism and dogma, which might normally be thought as being at odds with one another. And we have, in lockstep with the increase of the so-called woke movements, a recent increase in the number of academics and what we might call allied experts, journalists, authors, public intellectuals and so on, who have become more and more vocal about postmodernism and the movements that follow postmodernism. This is a good thing, and it has led to something of an upsurge in interest by bloggers and others online about the culture on university campus. This pushback against postmodernism and the rejection of finding the truth, or even recognising there is a truth out there worth seeking and understanding, questioning and debating and taking seriously, can in many ways be seen to find its roots in the Popper-Wittgenstein divide, so I would argue. Another landmark that came later was the so-called Sokal hoax. And recently we've had Pluckrose, Lindsay and Bokosian repeating the basics of that earlier Sokal study, demonstrating the lack of content or critical analysis of some academic journals. So we've had Jordan Peterson, Sam Harris, Douglas Murray, Nicholas Christakos, just to name a few of the bright lights of our time, writing or speaking about the problem as it manifests itself in tertiary education. It has perhaps reached a crescendo of sorts among some students following the indoctrination of their lecturers who reject mainstream science, or as they might have called it, Western science, or Eurocentric, or male science, and so on. So Peterson, Bokosian, etc., they are concerned about what is quite perversely called studies in critical theory. I would say critical only in the very narrow sense of being critical, often unfairly and dishonestly, of Western culture specifically. Modern so-called critical theory is not critical of its own content, unlike, let me give a plug here for Popperian epistemology, critical rationalism, which is criticism applied to everything, including itself. More commonly, this new critical theory is more accurately labelled and maligned as grievance studies. In my own field, there's been a recent push to remove references in physics to dead white men. I'm possibly going to consider that issue in a blog post soon. But my purpose here now is not to look at the present concerns about this rejection of truth and the embrace of relativism. Douglas Murray's book, The Madness of Crowds, articulates some of the most egregious events and serious effects of that culture downstream of academia, and what can happen when postmodern doctrines are taught and then taken seriously. Instead, here, I offer Popper's defence of philosophy broadly, and rejection of what might be called the first seeds of contemporary relativism. It was planted, it would seem, by Wittgenstein. Wittgenstein, it must be emphasised, was no relativist. He was a realist of a kind, and certainly embraced science as a route to truth, indeed the only route. He more embraced scientism, really. But he did plant the seeds of relativism, innocently, ignorant about what they would go on to spawn in philosophy and wider academia later. This happened because he argued that philosophy was but a language game. He argued there are no philosophical problems, he argued for the supremacy of language, and in doing so, pushed open a door to so much nonsense in philosophy and misconception about the purpose of philosophy. As we've already seen, this led to the invention of a whole field of philosophy, the linguistic philosophy, and that led to postmodern deconstruction, a way of undoing meaning, taking sense, turning it into nonsense, and that led to some of the situations we now find ourselves in with race studies, third-wave feminism, Marxist retellings and reimaginings, and more besides. Understanding these moves and some of the philosophical background can help us to understand where we're at today. Understanding where some of this went wrong might help us to correct our course. On my website and linked to this episode, you can find Popper's original paper, A Defence Against the Dark Arts of Postmodernism, and my commentary upon that paper. It's meant as an articulation of a realist position in philosophy. Philosophical problems exist, and thus, so too do their solutions. Throughout my discussion, which I'm going to take one page at a time, thus turning what is a quite dense 33-page journal article into something somewhat more concise and I hope more simple to read, I'll also refer the reader and listener to Wittgenstein's Poker to provide a little more of the surrounding background to this debate. And it wouldn't be me unless I also referred you to The Beginning of Infinity. In this case, Chapter 12, A Physicist's History of Bad Philosophy, touches on this and has lots of concise and humorous remarks about the philosophical dead end that Wittgenstein led large parts of the field down into. Together, these sources paint a vision of the seeds of Popper's worldview and what might be said to be some of the fertile ground David Deutsch has used to cultivate and refine some of this optimistic vision of reality. So of course we begin on page 1 of the paper, and here Popper's arguing that philosophy, like science or any discipline for that matter, is not distinguished so much by its subject matter as by the problems that are investigated. So the question, what is philosophy, says Popper, is a rather pointless one as it leads the questioner down a road of essentialist answers. And we are bound to end up in arguments about whether some bit of subject matter really is philosophical rather than scientific. Over on the second page, Popper explains that the reason we separate subjects is largely due to historical reasons and matters of administrative convenience. The populariser Sam Harris follows Popper on this exact point, in fact, and has made this point repeatedly. For example, where he writes, this is from his website, the boundaries between true intellectual disciplines are currently enforced by little more than university budgets and architecture. Is the Shroud of Turin a medieval forgery? This is a question of history, of course, and of archaeology, but the techniques of radiocarbon dating make it a question of chemistry and physics as well. And that's from samharris.org, blog item, Our Narrow Definition of Science. I think that Sam must have read this same paper. It's got a lot of echoes of Popper's writing here. Anyway, Popper explains that the question of what is philosophy, like the question of what is science or what is geology, is always open to revision because the subjects always tend towards unification, and we should be students of problems rather than subjects, and problems cut across disciplines. Popper uses the example of geology. The problem of finding uranium is going to include physics and chemistry and lots of things. Popper then says that although this view of problems cutting across disciplines is true, nonetheless, problems can still be seen as arising out of one subject or another. This second page that he asks his central question, are there philosophical problems? This is the question that separated him from Wittgenstein. The paper then moves into Popper explaining Wittgenstein's position. In Wittgenstein's view, the answer is no. It's a no because all actual problems reduce to scientific ones in the final analysis. Philosophical problems on this view are pseudo-problems, a result of misunderstandings in language rather than anything truly substantive. So philosophy is not a place where you form theories as such, explanations of reality, moral, political, epistemological, meta-scientific and so on, but rather it is an activity where we simply unmask philosophical nonsense. And Popper would agree that unmasking philosophical nonsense is an important part of philosophy, but not all of it is reducible to this. I'm up to the fourth page now, and Popper flags for us that he's about to explain, defend, and then criticise Wittgenstein's position. And this is, of course, completely in line with his philosophy of philosophy. The arguments of your opponents should always be put in their strongest possible terms, at least as well as your opponents would, if not better than what they would. But whatever the case, not in the way that you would expect they would obviously object to. And so this is what some people call steelmanning. To me, there seems to be a strong form of steelmanning, which means something like making the case of your opponent even stronger than what they intended. This doesn't seem to me to be advisable because that might not be what your opponent intended. But there's a weaker form of steelmanning that I think is uncontroversial, and it's something like Popper would endorse, which is to as fairly, clearly and accurately represent the position of one of your opponent in terms they would not object to. Popper says here that a philosopher should do philosophy, which is to say philosophize, and not just talk about philosophy or the work of other philosophers. This, of course, is exactly what I'm doing and what I usually do, but in my defence, I'm not purporting to do philosophy here and now. I'm attempting to be a philosophy communicator, if anything. Whatever the case, Popper says that if he thought Wittgenstein were correct, then he, Popper, would give up philosophy. Talking about philosophy is clearly not for him. He wants to solve problems in philosophy. That's what drives Popper, not waxing lyrical on the work of others. But he says the reason, of course, he does talk about philosophy is, eventually, to get to philosophizing, which is to say, solving some problems. And I think many of us in the critical rationalist community kind of try and do this. We might talk about the work of other people, but it's only so that we can engage with the academic pessimists, the prophets, the justificationists, the pseudoscientists, and so on, so that maybe we can address some philosophical problem underpinning them, okay, to address the misconceptions. And so, like Popper, if only modestly, to make some headway towards clarity on those topics. But, I myself readily admit I spend far more time on all the ways certain ideas are false rather than making headway on what is actually true. But moving on, this is where Popper says on this page that the gulf between science and philosophy happens to be a recent one, and that this led to Bertrand Russell influencing Wittgenstein via his classification of expressions in a language into three kinds. This is Russell's classification system. He said that there are true statements, false statements, and meaningless ones. So here we've got Popper tracing Wittgenstein to Russell. We can't blame Russell for Wittgenstein, however, in the same way we can't blame Wittgenstein for schools of grievance study today. He'd likely be horrified by them. But it is informative to see the philosophical roots of these ideas and thus excavate the underlying error or the root of the error. For it is somewhat like geology in that respect. How was that metamorphic rock generated? It was only possible given, for example, the deep compression, stress and warping of the other kinds of rocks like sedimentary or igneous. In other words, the local conditions caused this warping. But a metamorphic rock is altogether a different substance than the igneous rock that was its chemical precursor. But its origins are still there, imprinted as it were, deep within its deep structure. So it can be with ideas. On to the 5th page, and Popper explains that part of the motivation for this was to distinguish between the false and meaningless statements as resolutions to logical paradoxes. So the former, a merely false statement, might be something like 3 times 4 is 173. But the latter, a meaningless statement, could be 3 times 4 are cows. Popper says Wittgenstein followed Russell down this road and concluded that, therefore, all philosophy consists of meaningless statements, and this meant there could not possibly be philosophical problems. Alleged problems in philosophy he categorised into 4 kinds. Actually logical or mathematical problems, actually scientific problems, combinations of those first 2 kinds, and the 4th kind, meaningless statements of the kind Russell had said. Now, here 1 and 2, problems being actual logical problems or problems being actual scientific problems, could of course be answered by the methods of mathematics and science. Popper says that Wittgenstein's proposal here was ingenious. It was an ingenious attempt to eradicate philosophy and theology, and it led to the creation of an entirely new school of philosophy. So we just note here, by the way, Popper conceding that Wittgenstein's idea of eradicating philosophy with the help of an adaptation of Russell's theory of types was ingenious and original, and more radical even than Comte's positivism, which it resembles closely. So Popper generously gives Wittgenstein his due. He's not berating his intelligence. He's not saying he's silly or stupid. Quite the opposite. He's praising his genius. He just thinks he's completely wrong, as geniuses often can be, or even almost always are, like the rest of us. On to the next page, and Popper for the first time introduces the problem versus puzzle dichotomy. Remember, Popper believes in genuine problems in philosophy, open, deep questions about reality whose solutions must be drawn from philosophical theories, whose purpose it is to solve problems just as scientific theories solve scientific problems. But this new school of language analysis that Wittgenstein founded said that all such problems were apparent only. In fact, they were language puzzles. And if you figured out where the language went wrong, the puzzle would be solved and the apparent problem would vanish. Popper says he fails to understand why language analysts would even want to do that job, if that is what philosophy amounted to. It seems like it's pointless. Why do philosophy if it's not about deep problem solving and instead is about puzzle solving, like spending your workday doing crosswords or something? Popper fully admits here that he understands some of the motivation. After all, many people speak nonsense and write nonsense, especially dangerous nonsense, and here he alludes to philosophy that leads to terrible political ideas, like communism or fascism, and of course today we would speak about postmodernism and critical theories and other kinds of woke activism. But then again, also, some of that, even when, say, it's nonsense only because it's poorly worded, might contain some truth worth listening to. In other words, not all nonsense is meaningless. It's as if Popper is claiming that some people who might not speak or write carefully, what he's saying to them is, well, what you've said there strictly is nonsense given your poor grammar. However, I understand what you're trying to get at, and your central point is understandable, and perhaps it's even true. Popper also uses the example here of calculus and mathematics, which, when it was first discovered, probably seemed to every other mathematician as nonsense. Calculus is the mathematics of continuous change. Until Newton and Leibniz invented it, mathematics was largely about geometry and counting or algebra. But calculus introduces the idea of limits and infinities of various kinds and infinitesimals in order to understand the concept of continuous change. The point here might also be something that might seem to be nonsense to you, or in some sense a contradiction to you, might nonetheless contain truth and be used to solve problems, as of course calculus can. One might be tempted to say that there is almost no area of physical science left untouched by calculus. Popper says here that it's understandable that people looked at the high-precision language of mathematics and compared it to the vagueness of philosophical language, and this was impressive to the followers of Wittgenstein. But Popper observed, had there been a Wittgenstein at the time when calculus was first created, he possibly might have attempted to eradicate the whole calculus project because of its similar vagueness, as it was only understood vaguely, like all new discoveries are when they are first discovered. The most famous statement ever uttered by Wittgenstein comes next. Whereof one cannot speak, thereof one must be silent. And Popper quotes Erwin Schrödinger's reply. And Schrödinger said of Wittgenstein, but it is only here that speaking becomes interesting. Wittgenstein's original quote there seems to have been interpreted in many ways. Firstly, in the strong sense, it can be used to dismiss all of metaphysics and theology. And two, and this is probably the way Wittgenstein intended in a weaker sense, it can be used to admit that there do exist phenomena, metaphysical or spiritual, for which no words are adequate and can only possibly mislead. And therefore, we should partition off statements about the world, our use of language, to be about things that are empirically true or false. So I think that's the correct reading of Wittgenstein. I don't think Wittgenstein, in the same way that Popper argued, that metaphysics was irrelevant or useless or not a real domain of inquiry. It's just that in Popper's case, he thought they weren't scientific statements, but were still valuable. And in Wittgenstein's case, he thought it was valuable to think of these ideas perhaps, but you just couldn't speak about them. There was no point debating metaphysics because they weren't questions which could be settled empirically. Now, moving on to page 7, Popper agrees that we should strive for clarity, but that language analysis could be used as a technique whereby scientific texts could be shown to be filled with meaningless pseudo-propositions and tautologies. So when you apply language analysis to scientific work, it might show that scientific work is itself meaningless. Popper here defends Wittgenstein. He begins with an admission that much of philosophy is meaningless verbiage, and that Wittgenstein did something to correct this, although Popper thinks Russell probably deserves as much credit or more credit for this because he had such a lucid style. Popper says that Wittgenstein is correct, that some schools of philosophy degenerate in such a way that its problems can become practically indistinguishable from the pseudo-problems Wittgenstein says they actually are. Popper argues that this is a consequence of philosophical inbreeding, where the philosophers search for issues within the subject of philosophy to the exclusion of those arising from outside. Philosophical problems in mathematics, politics, religion or science, for example. Popper presents his first thesis. And the first thesis is, genuine philosophical problems are always rooted in urgent problems outside philosophy, and they die if the roots decay. So Popper argues that philosophers get sidetracked when they think there is some method to philosophy that is like some recipe which produces truth if only you follow it carefully. On to the next page, page 8. Popper speaks about how methods do not matter in philosophy. What matters is careful attention paid to and passion for problems. Popper distinguishes two kinds of thinkers: those who like problems, people who feel that the problem is so real, it is like a disorder they just have to get out of their system. It is all-consuming. And on the other hand, those who just apply some technique already known, which is to say, puzzle solvers. Here, he is agreeing with Wittgenstein that such puzzles indeed exist, and there are people who pursue them, even in philosophy. But he just disagrees with Wittgenstein that all problems in philosophy are ultimately puzzles in language. Popper makes the point that philosophy education is idiosyncratic in this regard. In philosophy, we give learners the works of the great philosophers. The Greeks, the Europeans, the big names between Plato and Descartes and Mill. The student reads these and then discusses the readings abstractly, and more perversely, might attempt to reconstruct the way those dead philosophers wrote, usually circuitously and confusingly because those original philosophers were not too sure of exactly how to conjure the language to write clearly themselves. David Deutsch makes this point as well, that philosophy, unlike physics, or any area of science, to which it is more closely related than, say, English literature, because science is a problem-solving process while literature is an appreciation process, philosophy is obscure in the way we read the original texts. But no physics student would ever learn relativity from Einstein's initial writings on the topic. They'd pick up a modern text. Why shouldn't a philosophy student do the same and solve philosophical problems like a physics student solves physics problems? In truth, though, much of physics learning is also sadly puzzles of the kind Wittgenstein complained about. A known method applied to a situation where the result is already known beforehand. On to the next page, and Popper says he understands how a competent philosophy student might come to Wittgenstein's own conclusion. Philosophy seems to have a peculiar jargon and a set of techniques which, once learned, makes one feel as though they have mastered the puzzle solving as well as anyone else. And this is a captivating thing. Popper says it is dangerously captivating because it leads straight to the conclusion that philosophy then is easily interpreted as being much ado about nothing, just a lot of nonsense. Of course, Popper thinks this is mistaken, but is the result of learning philosophy in the traditional manner. Popper doesn't dismiss the study of ancient philosophers. I mean, he did as much of this as anyone else, of course, but says that a true understanding of the problems that motivated them is only properly gained by studying the relevant history of the time, the history of mathematics and science, which these philosophers were often animated to be writing about. So philosophers need to be familiar with those fields to understand the problems and therefore understand the philosophies built to tackle those problems. So I'll say that again in my own words. Philosophers really need to be familiar with problems within science and mathematics in order to appreciate the philosophical problems in those areas at a given time. And so today, there are philosophical problems at the heart of physics and mathematics. But philosophers can only make a contribution to these philosophical problems if they're familiar with science and with mathematics. Popper emphasises that Wittgenstein is right that so much of philosophy as practice is consumed by a concern about non-philosophical problems. And Wittgenstein is right to reject philosophy as it is largely practiced. Popper on page 10 then goes on to expound upon Wittgenstein's doctrine, which is that pure philosophical problems do not exist because the purer it becomes, the more is lost of its original significance and degenerates into empty verbalism. Now, Popper, in contrast, says, but there do exist genuine philosophical problems as well as scientific problems. Some problems in philosophy can have factual components, but might not be scientific. And even if they can be solved by logic, they are not problems of logic. He refers the reader to comments on page 2, where problems in science cut across boundaries of science. Popper refers to cosmology as an example. There, the problems have been philosophical, and so Wittgenstein would presumably rule them out as meaningless or as puzzles of language. I would guess, for example, that the question about whether the universe was infinite or finite would be a question that Wittgenstein might have regarded as perverse at some point. But now, of course, it is more a scientific question than one of metaphysics. Whatever the case, The fact the origins and evolutions of the whole universe are now more closely allied to physics than to philosophy does not mean that at one time the questions were not meaningful. And in actuality, being meaningful could not be addressed by non-scientific means, because no scientific means were available at the time. Indeed, today we now have precision instruments for measuring cosmological parameters. We can say that cosmology is most definitely a science. So much for the two fields, science in the form of cosmology and philosophy being entirely separate. Popper says that Wittgenstein's doctrine is a result of his thesis that there are two and only two classes of statements: synthetic a posteriori, which are things true after the fact, the truths of science or history, for example, and analytic a priori, logical statements like the truths of mathematics. Just as a side note here, I should throw in a quip. A lecturer of mine who was a great fan of Wittgenstein, as many of the philosophy department out at the University of New South Wales were, he would bring up this quip about whether or not there can be synthetic a priori statements. For example, what's the length of a metre? It's true by definition, but it could have been otherwise. I'll just dwell on that esoteric concern about philosophical jargon for a moment. The synthetic analytic distinction is about whether a statement is true by definition or not. Analytic statements are simply true by definition, like bachelor's a male. The bachelor bit already contains the male bit in it. The a priori, a posteriori distinction is about whether something is true from experience, a posteriori, or independent of experience, a priori. So the quirky, interesting case here is that some things can be true by definition, but also true only from experience. So the quirky, interesting case here is, can some things be true by definition, but also true only from experience? Which means something occurring in the world. Well, the interesting example is the length of the metre. The length of the metre is a metre by definition, but it could have been some other length. Okay, it could have been half the length that it was, but a metre is always a metre. Now, Popper, in fact, has a footnote on this page here and says that Wittgenstein's insistence of a two-pronged delineation of statements is too simple, but he doesn't give an example. So I would say the length of the metre example probably accomplishes that. I'm now up to page 11, and so Popper now gets into specific examples of how there are indeed philosophical problems. And we need to go outside of philosophy to see why. His first example is about Plato's theory of forms, and this is one that we're going to spend quite a while trying to get a handle on. Essentially, it's the idea that there is a world beyond the physical world. It might be supernatural or not, it doesn't need to be, but it is a world of ideas, or better yet, ideals. And the physical world is just an imperfect manifestation of that other world. Now, if you completely strip what Popper calls the problem situation away, it might seem to be a fairly silly concern to worry yourself with. But we can only look at this question of whether or not a realm of forms exists and whether a theory of forms is required if we put ourselves back at the time when Plato was trying to understand what was happening in broader Greek thought at the time. The Greeks were trying to understand the nature of matter. So it was a scientific question they were trying to understand, but it is a philosophical problem as to whether the forms exist or not. And onto the next page, Popper connects this theory of forms to the Pythagorean notion that all is number. That came earlier. Strangely perhaps, Plato's theory of forms really arose out of an understanding about the irrationality of the square root of 2. This means 2 cannot be represented as a fraction, and I'll put my own version of the proof on my website. Pythagoras and the Pythagoreans argued that all is number because they were impressed by musical ratios that were mathematical, or how the leaves on a tree could be folded to form a cross, and the length of the sides of the leaves were Pythagorean triads like 3, 4, 5, or 5, 12, 13, etc. Onto page 13, we get this idea that shapes, fundamental shapes like squares and triangles, are produced by adding simple numbers, and these numbers are called gnomons, which are the numbers added to a figure to generate some pattern. So for example, if you take the square numbers, so 0, 1, 4, 9, 16, 25, in other words, 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Well, each of those numbers differ one from the next by the sequence 1, 3, 5, 7. Okay, the odd numbers. And if you add these numbers together, you get the square numbers again. So 1 plus 3 is 4, 1 plus 3 plus 5 is 9, and so on. So the sum of the odd numbers produces the square numbers. Or more formally we say, the sum of the first n odd numbers adds up to n squared. A similar thing happens with triangular numbers, where the differences between the triangular numbers makes the sum of the first n natural numbers. The triangular numbers are 1, 3, 6, 10, etc. How you make a triangular number is you take a single dot, that's your first triangular number, and then you take 3 dots and you form them into the shape of a triangle, and that's the number 3. And then to make the next triangular number, well, you add 3 more dots to the base of that triangle that you've already drawn, and you end up with 6 dots. So in other words, you're drawing pictures of triangles using dots, and that's what the triangular numbers are. And so you've got 1, 3, 6, 10, etc. The differences between those numbers, you get a new sequence. You get 1, you get 1 plus 2, you get 1 plus 2 plus 3. So you're adding up. And Popper goes on to continue this example to explain other more complicated cases. And then the extension to 3 dimensions. So to create pyramidal numbers, we just add the triangular numbers for a triangular pyramid, or a tetrahedral number as they're called. So you end up with 1, 4, 10, 20. And they're the sums of the first n triangular numbers. So remember what the triangular numbers are. 1, 1 plus 3, 1 plus 3 plus 6, 1 plus 3 plus 6 plus 10. So to generate a shape or a form, we're doing nothing but arithmetic. Okay, so this comes from Pythagoras. It bleeds through into Plato. All you're doing to generate shapes, you can draw pictures of these things using little dots. And in Popper's paper, you can see the pictures of the little dots. And in fact, that goes all the way back to the Pythagoreans. What we say is that the shapes are generated by the numbers. They take seriously the idea that any shape is just generated by iteratively adding particular numbers. And the numbers that you're adding are called the gnomons. Now, so therefore, are all shapes reducible to numbers? Well, this is the underlying problem that faced Plato. And this very much leads to the so-called reality of abstractions. So, having established that numbers have a real and autonomous reality, that is in some sense prior to the physical world, Plato then extended the notion to other abstract concepts beyond just numbers. So Popper remarks that this method of generating shapes by the addition of dots could go some way to explaining why the ancients turned to the night sky and found the dots, the stars there, and formed them into a zodiac of supernatural beings. Perhaps it is the case that a line is just another arrangement of dots and thus has a number. Or a scorpion is just a number. So the forms are the heavenly shapes of all objects. And so we are led to the notion of even abstract ideas having an autonomous reality, as would their opposites. So you have justice and injustice, good and bad, odd and even, male and female, health and beauty, and etc. The ideals are thus the domain of certainty and of a higher reality, which is unchanging because it is perfect. But the visible world is in flux, and it's changing. And so we cannot obtain certain knowledge of it because there are no certainties here. Popper says that on Plato's view, what can be obtained in the place of knowledge, more correctly, so we have to be careful here. When I use the word knowledge, more often than not, in this paper, we're talking about the Greek concept of episteme, which is certain truth. So what can be obtained in the place of that, this certain truth, are only the plausible but uncertain or prejudiced opinions. More commonly, these are called a doxa, or seeming, or fallible mortals. On to page 16, and Popper explains how the Pythagoreans considered that because all was number, when we find a length or measure, what is really going on is we are counting numbers, the number of invisible little dots. Now, because we cannot possibly see the little dots, a measurement reveals by an indirect method a ratio of natural numbers. Popper makes some remarks here about Pythagoras' theorem, namely that the Pythagoreans were not aware of any geometrical proof of the theorem, and nor was Plato. However, they were able to get close to an arithmetical proof of the theorem, so long as they assumed all numbers were rational. Of course, crisis now loomed, because as is famous in mathematical folklore, the Pythagoreans discovered the irrationality of root 2. If there could exist a thing, such as irrational numbers, then there was no ratio of sides for all triangles. The little dots were insufficient to the task, and base reality couldn't be number in this way. In particular, a square could be drawn with side length 1, and the diagonal was a number that could not be expressed as a fraction, or a simple ratio. Popper does mention that early on these irrationalities like root 2 were not even recognised as numbers. They were just magnitudes, whatever that might mean. Popper emphasises that these dot diagrams of the Pythagoreans seem to be proto-atomic theory and may have influenced Democritus. Other influences upon early atomic theory were Zeno, and in both cases they were seeking to explain change. Popper says that some of the early thinkers, like Parmenides, were theoretical physicists, utilising a hypothetical deductive system. They recognised that facts of experience could rule out their theories, and so they incrementally improved them as time went on. In the case of Parmenides, he concluded change was impossible, and so all we thought was change was merely apparent. This is not such a silly idea for an early thinker, because if something, call it X, changes, then X, the thing at the beginning of the change, remains at the end. Or else, X ceases to be, and we cannot say X changes, but rather something like X ceases to be and something else comes into being, say Y. But that is just to say that X exists and then Y exists. So X did not change and nor did Y. This is my version, by the way, of the no change is possible thesis. So Parmenides concludes change is impossible. However, these early attempts at creating fundamental theories in terms of form or number really were not physical theories. The first of these was Democritus' atomic theory. Even so, with Parmenides' theory of no change, one might consider Einstein's four-dimensional spacetime as being a theory of no change. All parts of spacetime, past and future, are there, equally real. That we experience change is just an artifact of our consciousness, a fact about observers and not about physical reality. The observer just becomes aware of the different spacetimes that were always there and are unchanging. On page 17, Popper fleshes out Parmenides' theory of no change some more. And I'm going to read directly from the paper here because it is a 6-line proof for what that amounts to. 1. Only what is. 2. What is not doesn't exist. 3. Non-being, that is the void, does not exist. 4. The world is full. 5. So the world has no parts. It is one huge block because it's full. 6. Motion is impossible, since there is no empty space into which anything could move. Now, given 5 and 6 are contradicted by facts, because motion is possible, we see it, and the world does have parts, then we can refute the remainder of the argument and we can work backwards. So 6, given there is motion, then 5, the world must have parts. It's not one but many. Therefore 4, the world cannot be full, and 3, the void or non-being do exist. Now, Democritus, he saw this argument about indivisibility, but he applied it to atoms rather than the universe as a whole. He took his atoms as being objects that were full and had no void inside. The point of this is that now it permitted a rational understanding of change. The world is a void, with atoms moving within it. All change is the rearrangement of atoms, and thus change is about movement in the void. Since the only kind of novelty that is possible is that of rearrangement, then it would be possible in principle to predict future states provided we manage to predict the motion of point masses. Finally, we're up to page 20 now. And it's here that Democritus' theory of change is explored in more detail, a theory which sets the scene for later developments in the physical sciences. Popper remarks that Democritus' theory of change was embraced by Plato, but not by Aristotle. Aristotle developed essentialism, the idea that substances had an essence that was unchanging, but they also had a potential which did change. Aristotle's theory failed to influence physics, but Democritus' idea that all changes movement had a massive influence. All the way through to today, with one important exception, David Deutsch's constructor theory, where change is most fundamentally about possible versus impossible transformations, of which movement is an emergent case. Popper does observe that some change, like the forces of Newton or the fields of Faraday and Maxwell, were not necessarily explicitly about movement. Popper writes on this page, quote, "Thus, we have a most interesting situation. A philosophy of change, designed to meet the difficulty of understanding change rationally, serves sciences for thousands of years, but is ultimately superseded by the development of science itself. And this fact passes practically unnoticed by philosophers, who are busily denying the existence of philosophical problems. End quote. So he's having a dig at Wittgenstein and Wittgenstein's followers there. Popper praises Democritus' solution to the problem of what causes change as being the framework within which properly scientific problems could be solved. And thus, we had an understanding of combustion and sound, the hardness of material, state changes in thermal physics, and so on. All from Democritus' attempt to provide a solution to whether or not matter had a fundamental nature, namely an indivisible form. Popper goes on to explain how Democritus' atomic theory established a philosophical methodological rule. A theory or explanation needed to be in agreement with experience. This is key. It's not quite falsificationism, it's prior even to that. Unlike with Aristotle, who seemed to reject experiment in favour of so-called pure reason, Democritus' physics proceeded on the assumption that explanations must be connected to our experiences or observations of the world. Also, Popper observes here that speculative theories about the invisible world, Democritus' atoms, could be accepted or rejected based upon observations of the visible world. And here we have the beginnings of the insightful way David Deutsch puts the issue, that often, very often, science is about explaining the seen in terms of the unseen. This philosophy, says Popper, the philosophy of being able to observe the seen as a check on theories about the unseen, is a solution that defends science against relativistic and positivistic tendencies. Let's just recall that a relativistic tendency is one which inclines one to reject truth, or observation or reality, while the positivistic tendency is one which inclines one to endorse the reality only of what can be observed, or which comes to us via our senses and nothing else. So to postulate the unseen would be anti-positivistic. Popper then introduces what he calls the most fascinating element in Democritus' doctrine, that of the quantization of space and time. Is there a shortest distance? Is there a shortest interval of time? Over on page 22, the motivation for Democritus assuming there was a smallest possible time and space was a response to the paradoxes or problems of Zeno. How can I pick up my teacup if there is a literally infinite number of points between my hand and the teacup, and to move from one point to the next takes some finite amount of time? Won't that sum to an infinite amount of time? Well, Popper introduces the story of the discovery of the irrationality of root 2. This is relevant, Popper says, because it dealt a fatal blow to atomism as applied to space. And so now I'm just going to basically put into my own words an explanation for the significance of the irrationality of root 2 on these early thinkers. The existence of root 2 means some lengths cannot be written down as fractions or integers. In particular, they cannot be written down as multiples of the shortest possible length. This idea that measurement must be about counting points, so in Democritus' view, all shapes, all lengths are just these made up of these indivisible smallest possible points, and you can put 2 points a distance, the shortest possible distance, one from another. So that idea that it's just about counting points when you're measuring things cannot be possible if it can be shown that some lengths are irrational. No finite number of dots can represent the length, that would mean. But this was the prevailing view up until that moment, the discovery of root 2. If there is a smallest possible length, then any length must consist of a finite number of atomic distances. Okay, atomic distance, smallest possible distance. But if the distance is root 2, or any irrational number, we cannot possibly have a sequence of dots that sums precisely to root 2. A simple example. If we made a square with a side length of the smallest possible length, so one atomic distance, so to speak, then what's the length of the diagonal? Well, the length of the diagonal is root 2. But that can't be measured in atomic lengths. It would be exactly root 2 atomic lengths, an amount that could not be represented by dots. Okay, root 2 is 1.4 something or other, so it would be one smallest possible length plus a little less than half the smallest possible length. Well, this is a strict contradiction. How can you have half a smallest possible length? That would be smaller than the smallest possible length. Popper explains that Plato noticed this fact, and it is Popper's belief that Plato's theory of forms was strongly influenced by it. Plato didn't agree with Democritus, but he had some sympathy with him, and his academy did teach the theory of Democritus. Popper writes that Plato realised that the purely arithmetical view of reality, that all is number, the Pythagorean vision, could not possibly be true. And this is why Plato built upon that and took elements of Democritus' own theory to develop his theory of forms. Ultimately, this led to a new mathematical formulation of reality. Another Platonist who followed Plato, Euclid. On to the next page, 24, Popper lays out his case clearly. So I'm just going to quote from the paper here. I'm just going to read part of the paper here. And Popper writes, quote, "What are the facts? I shall try to put them all together briefly. 1. Pythagoreanism and atomism in Democritus' form were both fundamentally based on arithmetic, that is, on counting. 2. Plato emphasised the catastrophic character of the discovery of the irrationals. 3. He inscribed over the door of the academy, 'Nobody untrained in geometry may enter my house.' But geometry, according to Plato's immediate pupil Aristotle, as well as to Euclid, treats of incommensurables or irrationals, in contradistinction to arithmetic, which deals of the odd and the even. 4. Within a short time after Plato's death, his school produced in Euclid's Elements a work whose main point was that it freed mathematics from the arithmetical assumption of commensurability or rationality. 5. Plato himself contributed to this development, and especially to the development of solid geometry. 6. More especially, he gave in the Timaeus, one of his writings, a specifically geometrical version of the formerly purely arithmetical atomic theory. That is, a vision which constructed the elementary particles, the famous Platonic bodies, out of triangles, which incorporated the irrational square roots of 2 and 3. In most other respects, he preserved both Pythagorean ideas as well as some of the most important ideas of Democritus. At the same time, he tried to eliminate Democritus' void, for he realised that motion remains possible even in a full world, provided motion is conceived of as the character of vortices in a liquid. Thus, he retained some of the most fundamental ideas of Parmenides. 7. Plato encouraged the construction of geometrical models of the world, and especially models explaining planetary movements. Euclid's geometry was not intended as an exercise in pure geometry, as is now usually assumed, but as a theory of the world. Ever since Plato and Euclid, but not before, it has been taken for granted that geometry, rather than arithmetic, is the fundamental instrument of all physical explanations and descriptions, of the theory of matter as well as of cosmology. Popper concludes that Plato's theory of forms was not meant to be a merely mathematical exercise. It was meant to be a theory of the world. So it led to this idea that we could even understand physics in terms of the motion of planets, orbits, as being about shapes, as being about geometry. Over on page 25, Popper writes that all of the preceding section amounts to an argument that Plato was solving a philosophical problem about what base reality was like. So a question of ontology or metaphysics. This wasn't strictly physics or mathematics, but it laid the foundation for so much of the physics that came afterwards. From Euclid, Aristarchus, Archimedes, Copernicus, Kepler, Galileo, Descartes, Newton, Maxwell and Einstein. This worldview, or even approach to epistemology, as being informed by geometry, that the base reality emerged from perfect forms, was a philosophical worldview that helped in the formulation of science that came much later, and only happened because of the problems Plato was trying to solve with respect to inconsistencies between Democritus' atomism, as applied to space, and the discovery of the irrationality of root 2. As Popper writes, quote, "This approach transforms a fundamentally theological idea, the idea of explaining the visible world by a postulated invisible world, into a fundamental instrument of theoretical science." End quote. Popper credits Democritus with this notion that visible matter was to be explained by hypotheses about invisibles, about an invisible structure which is too small to be seen. And Popper writes, quote, "With Plato, this idea is consciously accepted and generalized. The visible world of change is ultimately to be explained by an invisible world of unchanging forms, or substances, or essences, or natures, as we shall see, geometrical shapes or figures." End quote. On to page 26, Popper then asks of this idea about the invisible structure of matter, is it a physical or a philosophical idea? He says that if a physicist acts on the theory, perhaps without even being conscious of it, accepting the problems of his subject, he might produce new theories of matter. In that case, he is not a philosopher but a physicist. But if he was to reject that philosophy, that matter has an invisible structure, then what he is doing is plainly philosophy. So Bishop Berkeley and Ernst Mach did this kind of thing. Mach rejected, if you might remember from the beginning of infinity, he rejected the idea that atoms could exist because he could not see them. Popper then says to worry further about whether we are properly labelling something as philosophy or physics is Wittgenstein's problem. It is one of linguistic usage, and so is indeed a pseudo-problem. Popper then turns to making some final remarks about Plato's theory of the structure of matter. In Plato's view, the smallest solids are crystal-like elementary particles, and in turn these particles have faces which are simple shapes. Hence we have atoms made of platonic solids, and platonic solids made of simple shapes. He goes further. The simple shapes, squares or hexagons and so on, are themselves ultimately all composed of two elementary triangles. The half square, also known as the isosceles rectangular, which has a hypotenuse of root 2, and the half equilateral, which has a root 3 side length. So we incorporate the irrationals into our new Platonic atomic theory. The triangles are the copies of the unchanging forms or ideas on this view. So it seems clear that atomism can incorporate irrationals, and we can once again have a fundamental theory of matter without contradiction. A hole in the theory that Plato seems to have recognised is that not all shapes can necessarily be made with tessellating those two triangles. Indeed, Euclid showed that more than just roots 2 and 3 were needed to specify any odd length. Lengths were not just multiples of those. Plato seems to hint that he understood this possibility. This, in turn, seems to have caused Aristotle to realise that Plato hadn't solved the problem he thought he had. He seems to have just introduced Democritus' problem of shortest possible distances, but now it was root 2 and 3 instead. So not everything could be shown to be a multiple. Not every length could be shown to be a multiple of root 2 and 3. So Aristotle seems to have thought Plato's theory was the same as the Pythagorean theory with a bit of a tweak. Ultimately, though, Aristotle was not particularly interested in mathematics, so he didn't write much about it. On to page 29, and in summary, Popper writes that Plato's theory of forms was somewhat of a restatement of the theories of Democritus and the Pythagoreans in light of his understanding of the irrationals, and this emancipated geometry from arithmetic. By encouraging this emancipation, Plato laid the groundwork for Euclid, the most important deductive system ever constructed, says Popper, and thus we can draw a relatively straight line to Aristarchus, Newton and Einstein, all of whom used the toolbox of Euclid. Popper wrote, quote, "The calamity of Greek atomism was thus transformed into a momentous achievement, but Plato's scientific interests are partly forgotten. The problem situation in science which gave rise to his philosophical problems is little understood, and his greatest achievement, the geometrical theory of the world, has influenced our world picture to such an extent that we unconsciously take it for granted." End quote. So all of that is about the fundamental nature of matter. And that was the problem, the philosophical problem that Plato was engaged in trying to solve. And it led ultimately to a theory of geometry which informs science today. And had Plato not tried to solve that philosophical problem, progress would have been hampered. Popper then turns to a second example of a philosophical problem. He says there are many examples that he could have used, but he's going to use Kant. He says that Kant's Critique of Pure Reason is one of the most difficult books ever written. Popper says Kant wrote too quickly and about an insoluble problem. It's not a pseudo-problem, but an inescapable problem, which arose out of contemporary concerns in physics. Kant wrote for an audience familiar with Newton, and even the history leading to Newton from Copernicus through to Galileo. Popper writes that it can be hard for us today to appreciate the psychological impact of Newtonian physics upon the early thinkers. Modelled after Euclid, the gravitational force of attraction was felt to be bordering on the occult. It had no explanation after all. It doesn't even have an explanation today, though one was initially demanded. Eventually, though, the success of Newton's theory was sufficient to have it accepted because of its power to predict to near perfection, where other contenders who tried to make similar predictions completely failed. Popper tries to give a sense of what it must have been like for those early thinkers to have it dawn upon them that Newton's theory is actually true. It was a unique event, says Popper, one that could never be repeated. The first and final discovery of the absolute truth of the universe. Mankind had obtained knowledge, real and certain divine episteme, or scientia, not merely doxa, not mere opinion. So for Kant, Newton's theory was simply true, absolutely true, and it remained this way in the opinion of every single thinker for 50 years after Kant's death. But Kant himself, although he at first embraced this notion of certain truth, became unsettled about it upon encountering Hume. What Hume taught, and what he taught Kant, was that there could be no certain knowledge. What we knew must be obtained with the help of observations, and observations of particular cases. So our knowledge would always be uncertain. So Kant in his mind had a contradiction of sorts. On the one hand, Hume's contention that repeated observations do not guarantee knowledge, and that's how knowledge must come to us. So we can't get certain knowledge. But on the other hand, the absolute perfection and certainty of Newton's theory. So Kant asked the question, essentially of Newton's theory. Here is a bit of knowledge, some certain truth. Newton's theory is knowledge. But how could it be obtained? It has been obtained, but how? The question was inescapable, but also insoluble. Insoluble because the idea that Newton's theory contained episteme, that is to say certain knowledge or incontrovertible knowledge, we now know that to be false. But Kant didn't know that, no one did. So it was a real and open question as to how it was possible to ever obtain it at all, given all we had were observations of the world. There is a philosophical problem if ever there was one. How is knowledge possible? How is knowledge creation possible? Now, we now know that Newton's theory is knowledge, just not episteme. It's conjectural. Popper solved that for us. Popper says we now know Newton's hypothesis was just that, an astonishingly good approximation. Unique for sure, but not divine and perfect. It is doxa in the final analysis, not episteme. Popper writes that Kant's own solution to his problem was a strange mix of absurdity and truth. He tried to say that our minds impose physical laws onto reality. We produce laws in the same way we kind of digest food. It's natural for us to somehow find these laws in our own minds, and then impose them upon nature. So the scheme seemed to work like this. Our senses gather data. These in our mind form themselves into mathematical relationships, and these we can then impose upon nature. So Kant is suggesting that natural science is not merely possible, it is necessary given our mental makeup. It then becomes rather amazing to Kant why it took so long for Newton to make this discovery. And it is an absolute mystery why everyone else didn't. Everyone else has a digestive system converting food to waste, so why aren't the rest of us converting perceptions into mathematical laws? Popper says we cannot dismiss this all so easily, even though it might sound absurd. It's no pseudo-problem, the question of how knowledge is possible. Popper frames this as the question, how are successful hypotheses possible? Now, Popper writes his own Popperian answer, so I'm just going to read it from beginning to end here in full. I can't improve upon him. Quote, how are successful hypotheses possible? Because, as you said, he's responding to Kant here, as you said, we are not passive receptors of sense data, but active organisms. Because we react to our environment, not always merely instinctively, but sometimes consciously and freely. Because we can invent myths, stories, theories. Because we have a thirst for explanation, an insatiable curiosity, a wish to know. Because we not only invent stories and theories, but try them out and see whether they work and how they work. Because, by a great effort, by trying hard and erring often, we may sometimes, if we are lucky, succeed in hitting upon a story, an explanation which saves the phenomena, perhaps by making up a myth about invisibles, such as atoms or gravitational forces which explain the visible. Because knowledge is an adventure of ideas. These ideas, it is true, are produced by us and not by the world around us. They are not merely the traces of repeated sensations or stimuli or whatnot. Here you were right. But we are more active and free than even you believed. For similar observations or similar environmental situations do not, as your theory implied, produce similar explanations in different men. Nor is the fact that we originate our theories and that we attempt to impose them upon the world an explanation of their successes, as you believe. For an overwhelming majority of our theories, of our freely invented ideas, are unsuccessful. They do not stand up to searching tests and are discarded as falsified by experience. Only a few of them succeed for a time in the competitive struggle for survival. End quote. So that's glorious. That is Popper there wishing he could speak to Kant, and that's what he would have said to Kant about Kant's own philosophy. And on the final page, Popper says that people today seem to have forgotten Kant's problem situation. What Kant, was trying to solve was a deep question about epistemology that Popper himself made progress upon. So in all these cases, this philosophizing that went on was not simply science or mathematics. It was motivated by particular problems in those areas, but it was not identical to those areas. It was deeper and prior, in a sense, to purely scientific or mathematical questions. Can matter be reduced to nothing but indivisible points or atoms? Does this mean lengths too must be quantized? But what then for irrational lengths? Popper says that many philosophers inherited Kant's terrible style of writing, but have failed to try and understand his problem situation. They are simply riffing on Kant or the work of other philosophers, rather than looking at problems outside philosophy that have philosophical content. And in conclusion, Popper writes, quote, "We must beware of mistaking the well-nigh senseless and pointless subtleties of the imitators for the pressing and genuine problems of the pioneer. We should remember that his problem, although not an empirical one in the ordinary sense, nevertheless turned out, unexpectedly, to be in some sense factual. Kant called such facts transcendental, since it arose from an apparent but non-existent instance of scientia or episteme. And we should, I submit, seriously consider the suggestion that Kant's answer, in spite of its partial absurdity, contained the nucleus of a philosophy of science." End quote. So that's quite amazing, I think. Popper gives Kant his due there. He was striving to understand how knowledge was possible. Kant was trying to understand how knowledge was possible because he thought Newton's theory of gravity was certain truth. But he also understood that the means by which we seem to come to understand the world was through observations. And yet, as Hume observed, this could not possibly generate certain truth. Popper is saying that Kant was dealing with a genuine problem. A problem, I'd submit, Popper solved in large part. Knowledge is generated by iterative cycles of conjecture and refutation, and knowledge remains conjectural, and it's an approximation to reality. But Popper says Kant's uneasy style of writing has been emulated by other philosophers. I guess in his mind he was thinking of Wittgenstein. So what we have here ultimately is Popper's concern that philosophy was being reduced to nothing but concerns over language. That was exactly the intention of Wittgenstein. And when you start to turn genuine philosophical problems into concerns over language, you overly focus upon the language. And so then everything becomes about the language. And I think we have important parallels today to the kind of issues that Popper was facing when he was debating Wittgenstein back in Cambridge all those years ago. This focus on language that Popper was objecting to is precisely the concern that some of our leading lights intellectually today are concerned about as well. It's subtly different, but it comes from a similar place. We have people like Douglas Murray who are concerned about real-world problems, and people like Jordan Peterson who are focused on real-world problems, but they've both identified that the other side is far too much focused on language, what people are saying, what pronouns people are using. In the case of Bokosian and the Sokal hoax type people, the fact that language is obscuring meaning in so many areas of academia. A concern about what language is permissible to use and what isn't, rather than a concern about genuine philosophical or ethical problems. It's a concern about the use of language. So these old debates have very real consequences for some of the political concerns today. Now, the context for this story, as I have said, can be found in Wittgenstein's Poker. So I'm drawing to a close now, and if you're really interested more about the sociological forces that come to bear on this, the book Wittgenstein's Poker by Edmonds and Eidenauer, I strongly recommend, and the scientific and philosophical consequences of the missteps that Wittgenstein made here, I think, are covered very well in chapter 12 of The Beginning of Infinity, where David writes about the effect bad philosophy has had on science, in particular on quantum theory. So that's another genuine philosophical problem. Is instrumentalism valid? What, if any, is the advantage of being a realist for a scientist wanting to make progress? Okay, but for now, I'm only up to chapter 10 of BOI, which will be coming out in my next episode, so I'll have to wait a little while until I get there to chapter 12, hopefully soon. Thanks for listening.